Hello everyone, welcome back to my channel. Today I am going to explain an interesting topic, multimedia databases. This topic is especially important in the fields of computer science, data science, digital media. So let's get started. The goal of this presentation is to introduce the concept and importance of multimedia database, to explain the types of multimedia data and how they are managed, to describe the architecture and storage models used in multimedia database, to explore content-based retrieval techniques and indexing methods, to highlight real-world application and to discuss detailed challenges, tools, etc. in that. By the end of this presentation, we were able to define what a multimedia database is and explain its significance. We will also be able to identify different types of multimedia data, how data is stored, indexed, and retrieved, comparison of traditional and different multimedia database system, and real-world applications. So let's get started. Firstly, we need to see what a multimedia database is. So a multimedia database is a type of database that stores and manages different types of media like text, audio, video, graphics, images, and even animations. Unlike traditional databases that handle structured data, multimedia databases deal with complex, unstructured, and semi-structured data. This database support content-based retrieval that we will understand further in the video, and it has many applications and efficient storage, fast access, and intelligent retrieval. So this is the comparison between traditional database and multimedia database. In traditional database, structured data type is there, tables, rows, and columns are used as storage formats. Query methods are traditional SQL-based queries. Indexing is done on keys and attributes. Volume of data is relatively small and retrieval complexity is thus low. Application are banking, inventory, employee records. Challenges are data integrity and normalization. Whereas in multimedia database, unstructured and semi-structured data type are used. Binary large objects are used as storage formats. Content based, that is CVIR query method is used. Indexing are done based on feature like color, shape, texture, and the volume of data is very large due to media file size, and thus the retrieval complexity is very high. Application are digital libraries, gaming, medical imaging, and challenges are large storage, real-time access. Multimedia is everywhere. Multimedia data is ubiquitous, and social media, entertainment, education, surveillance, and medicine. Businesses need systems to efficiently store, retrieve, and manipulate such data. Enhances user experience through content recommendation and search personalization. Thus, a multimedia database are very important in today's world. Characteristic of multimedia data are large volume, complex structure, temporal and spatial attributes, heterogeneity, and real-time data transfer. There are multiple types of multimedia data, that is text, images, audio, video, graphics, and composite multimedia, that is it includes each or any of the data types. Each of these data type has their own format and their own way of representation. Also, the data types are categorized into three types, that is static, which includes image and graphic object, dynamic, that includes audio and video and animation, and dimensional media, that is 3D game and CAD programs. This is the architecture of multimedia database. It generally has three layers, that is user interface layer and application logic layer, that is this layer, and this is the storage layer. So user interface layer provides interaction with the user. It allows user for uploading, querying, and retrieving multimedia content, whereas application logic layer is used for query processing and optimization, feature extraction, content-based retrieval logic. Whereas storage and database layer, it manages storage and retrieval and stores raw media files, metadata, and feature vectors for search. Workflow of the architecture is user submits a query, features are extracted, compared with the database, and then results are displayed. Data storage models are basically of three types: file-based storage, object relational model, and NoSQL database. Now, why index multimedia? As we have seen that multimedia files are very large, thus the multimedia database is very large, so it is impossible to get faster results in such a large database. So to overcome this problem, indexing is used. Indexing are of different types, that is keyword based, content based, feature based, and temporal indexing. Let us see content based image retrieval. It is a technique that retrieves image from database based on visual content rather than text based metadata. How it works? Feature extraction like color, shape, texture are extracted from the image, and then from this extracted features a numerical vector is converted to it. User provides an image or sketch, that is query input, and then similarities are matched from that query vector with stored vector. And after that, similar image are retrieved and trained. Now, extraction is a process of converting multimedia content into measurable features like color, shape, texture, pitch, and for each data type there are different features. The purpose of feature extraction is to support content-based search, enable fast and accurate media retrieval. Similarity measures are mathematical formulas used to compare feature factors of multimedia content and determine how closely they match. Common similarity measures are Euclidean distance, cosine similarity, Manhattan distance, histogram, intersection, correlation coefficient. These are used in multimedia database to find visually and audibly similar content. There are different types of query in multimedia database, that is keyword based, which is the traditional search using text or metadata. Content based, it uses low level features like color, shape or sound, and there is semantic query based on high level concepts like objects, scenes and emotions. Multimedia has vast application, that is digital libraries, news on demand, video on demand, music database, even in geographic information system and marketing. The tools and software used in multimedia database are MySQL with blobs, MongoDB or GridFS, Oracle Multimedia, and Elasticsearch. Recent advances AI/ML based tagging and retrieval, deep learning models for feature extraction, multimodal databases, and cloud based multimedia database for scalability. Then too, there are some issues and challenges which are faced by multimedia database. As multimedia database consists of a variety of media formats, and because of restriction on the conversion from one format to another, the use of data in a specific format has been limited as well. Also, the size of data is very large, and therefore multimedia data often requires a large storage. Multimedia database consumes a lot of processing time as well as bandwidth, and this takes much time in retrieval than standard database structures. So, to sum up everything of this video, multimedia database handle diverse media types like text, image, audio, video, and animation. Unlike traditional database, they support content-based storage, indexing, and retrieval. Key components include feature extraction, indexing, and similarity measures to enable smart search. Techniques like CBIR and query by example allows user to search using actual media instead of just text. Applications span across healthcare, entertainment, surveillance, education, and digital library. With the rise of AI and big data, multimedia database are evolving rapidly to meet modern demands. Thank you for watching and see you in the next video.